You can see 4 reactions I have shown here on the screen. These are just to recap the things we have done in last week lesson. In the last week lesson, we talked about different types of reactions of sodium. The first thing we discussed was alcohol reaction of alcohols with sodium. Second one, dehydration reactions of alcohols. Third one, reaction with chlorinating substances. And we are in the oxidation lesson. Alcohols are special type of compounds having OH functional group. And this OH functional group of alcohols participate in chemical reactions differently. If you think about the very first reaction with sodium, what happens when alcohols react with sodium is, I'll explain using an example. CH3, CH2, OH. This is ethanol. If you react ethanol with sodium, you can see hydrogen gas bubble formation. Sodium piece sinks in alcohol and start giving hydrogen gas. And then the alcohol changes to CH3, CH2, O minus, Na plus. This is called an alkoxide, generally alkoxide. And this alkoxide is sodium ethoxide. Sodium ethoxide. We discussed this in the last week lesson. And then we go to dehydration reactions. Dehydration means removal of water molecule. When an alcohol is reacted with dehydrating agents, we have 2 dehydrating agents discussed in our syllabus. First one is aluminum oxide and heat. This is one dehydrating agent. The next one is concentrated sulfuric acid, H2SO4 sulfuric acid. It should be concentrated, and it's not enough. We had to have about 180 degrees Celsius. You can write 107 degrees Celsius also. When you dehydrate an alcohol, water molecule goes out. For example, if I take this compound CH3, CH2, OH. It removes a water molecule and produces CH2, double bond CH2. An alkene molecule is formed. This is dehydration. This is also called an elimination type of reaction also. Elimination because water molecule goes out. Here, the reaction happens in this manner. I'll take this CH3, CH2OH for the discussion again. CH2H. I wrote CH2 differently. CH2 and one more hydrogen is going down. And in the next carbon atom, we have CH2OH. Dehydration occurs when a water molecule goes out in this manner. Now, this is alpha carbon. Alpha carbon has OH. Next to alpha carbon, we can say beta carbon also. Beta carbon has a hydrogen to go with the alpha carbon OH. So we get alkene. However, remember, if I give an alcohol like this, CH3, CHOH, CH2, CH3. If this molecule undergoes dehydration, can you tell me how many products will be formed? You can give me the answer. How many products will be formed when this molecule, when this alcohol undergoes dehydration? So up here, number 1, if I say A. A is a reaction of alcohols with PCl3 given halogen of alkane and H2PO3. If you react this alcohol with PCl5, then we get the same halogenoalkane, HCl plus POCl3. Third reaction, if this alcohol is reacted with thionyl chloride, we get halogenoalkane, HCl, and sulfur dioxide also. However, if you use HCl, then we get H2O. So likewise, there are 4 things. It is for this reaction with chlorinating substances. Now I go to oxidation. This is what we were doing last time, until like this. This is a summary. Alcohols when heated with acidified. When heated with acidified KMNO4. KMNO4. Alcohols when heated with acidified KMNO4. First point is primary alcohols change to carboxylic acids through aldehydes. That means the alcohol changes to an aldehyde first. In the second step, it goes to a carboxylic acid. It's about primary reactions of primary alcohols with acidified potassium permanganate. Now we'll go to second one. It's about secondary alcohols, not primary. Secondary alcohols change. Oh, this is primary alcohols change. Secondary alcohols change to carboxylic acid through aldehydes. And the last one, the third one, are tertiary alcohols. Do not undergo oxidation. Tertiary alcohols do not undergo oxidation. They don't change. These 3 important things we discussed in the last week lesson. Let me open this again. I will just revise this. Reaction of oxidation of alcohols to make different products. Alcohols can undergo oxidation reactions when heated under reflux with acidified potassium dichromate solution. Remember, tertiary alcohols do not oxidize. Secondary alcohols oxidize to form ketones. Ketones contain the following functional group. Ketone should have a carbonyl functional group. Always. Carbonyl functional group. On one side, we have an alkyl group. On the other side also, we have an alkyl group. That's the meaning of this. Now, alkyl group can be CH3. It can be CH3, CH2. It can be CH3, CH2, CH2. Anything, an alkyl group. There should be 2 alkyl groups attached to carbonyl functional group. Then it becomes a ketone. We will be doing after this, towards the second part of the lesson, I will start ketone lesson also. However, this is an introduction to ketones here. Few examples for common ketones are, here there are 2 alkyl groups. attached to the carbonyl functional group. And these two groups are taken with the middle carbon atom for the single chain, which is needed for chemical naming of the compound. Because it has 3 carbon atoms and a double bond oxygen, it is a propanone. Propanone means 3 carbon containing ketone. What is this ketone? 1, 2, 3, 4, but. But, here, this one has changed. Butanone. We can remove it. Butanone, butanone. Because there are 4 carbon atoms. And here we have 1, 2, 3, 4, 5. Pentan 3-on. Because the carbonyl functional group is on the second carbon, so pentan 3-on. See this example. In A, we have an alcohol. Always remember the type of alcohol given to you. This type of alcohol given to you is here. This is alpha carbon. It is attached to 2 carbon atoms. So this is secondary alcohol. Secondary alcohols go to, I said, ketones. Okay. Propanone has been formed. It's a secondary alcohol giving a ketone. And this compound is secondary. It is also secondary. Secondary alcohols go to ketone. Always secondary alcohols convert molecule into a ketone. The note says primary alcohols oxidize to carboxylic acid through aldehydes. In the exam, we don't have to talk about through aldehydes. If you know, just goes primary alcohols go to carboxylic acids. Answer will be accepted. Primary alcohols oxidize to carboxylic acids through aldehydes. That's what we explained. Now, because the note says through aldehydes, it's worth spending some time to talk about these reactions. Propan 1-ol converts to propanoic acid via propanal. So this is a primary alcohol. Why primary alcohol? The alpha carbon in this alcohol, alpha means the carbon atom to which the OH group is attached. So this alpha carbon has CH3, CH2 part on one side. We can convert this compound into an aldehyde function. What we do here is this hydrogen in OH goes with the hydrogen on the other side. So because this OH bond breaks, this oxygen makes double bond with carbon. So the structure will be CH3, CH2, COH. So here we say propan 1-ol goes to propanoic acid. Propanal goes to propanoic acid. Propanoic acid will not react again. See in the last example here, we can see pentane 1-mole. Pentane 1-mole goes to pentanal. Pentanal changes to pentanoic acid. For all these reactions, we use acidified potassium dichromate and heat under reflux. Under these conditions, the reaction will happen. This conversion can be done by using the following operators. What is this conversion? Alcohols to carboxylic acid. I have shown here acidified K2Cr2O7 in green because these are going to be used as oxidizing agents. Now, when you want to do this oxidation, what we do is we take an alcohol, add some concentrated sulfuric acid, and the alcohol. Solution is orange because of acidified potassium dichromate. And when it changes, after some time, we can see the solution in the round butter flask slowly decreasing. Okay, I'll just ignore it. This condition is called heat under reflux. When you put all the necessary things and heat here, it will go to green solution. Green solution is because it has chromium 3+ ions. From where is chromium 3+ ion coming into this? From potassium dichromate. So when you go on allowing this reaction, it goes on heating. During this reaction, when alcohols change to carboxylic acid, alcohol change to carboxylic acid, this is called oxidation. Alcohols go to carboxylic, alcohols go to oxidation. Okay, when the oxidation occurs, alcohol is oxidizing. In K2Cr2O7, it reduces. Reduces means in acidic medium, Cr2O7 2-. This dichromate ion goes to chromium 3+. Chromium 3+ is green. So the solution goes to green because there are chromium 3+ in the solution. So likewise, we allow the chemical reaction to occur. And finally, we extract the alcohol from the system by using fractional distillation. You can read this a little bit. I have used a very, very clear language so that anyone can understand. This is about oxidation reactions of alcohols. Primary, secondary, and tertiary alcohols, they react differently. You can see the apparatus clearly. This is your homework. We go to the next one, esterification reaction. Fifth alcohol reaction, esterification reaction. Okay. When ethanol reacts with butanoic acid, we get ethyl butanoate. If ethanol reacts with propanoic acid, ethyl propanoate. If propanol is reacted with ethanoic acid, to give water and an ester molecule. So likewise, we can find the names of compounds, and when they react, what will be produced. That idea is also given here. So with that, I guess alcohol lessons are over. I'm going to write some reactions. Let me check what we were trying to do again. This is done ester molecule. When you name an alcohol, first we have to give okay. The formation occurs when alcohols react with carboxylic acid. I will give a list of alcohols and carboxylic acids first. First one, let me take methanol. Methanol, if reacted with a carboxylic acid, I'll give the name of a carboxylic acid, ethanoic acid. Ethanoic acid. And then I'll go to another alcohol. This time I will take ethanol. Ethanol can react with a carboxylic acid. Carboxylic acid, I will take propanoic acid. Propanoic acid. And next one, maybe I can use again ethanol. Ethanol. Ethanol can react with, let's say, methanoic acid. Methanoic acid. Shall I take another one? This time I will take propanol. Propanol also can react with, or maybe ethanoic acid. When alcohols and carboxylic acid react in that manner, we get an ester. What is the name of this ester is what I'm going to explain to you now. It's very easy to get the name of the ester form during this reaction. What we do is this. Always, the methanol part is named in the ester name first. From methanol, we take methyl. From methanol part, we take methyl. I'll keep it in red. Methyl. So when you look at the name of an ester, the first part tells you what alcohol has participated in the formation of an ester. And then the second part of the ester comes from the carboxylic acid, ethanoic acid. It is known as ethanoate. Name of the ester is methyl ethanoate. And there's a water molecule also going out when the two molecules join together. Because water molecule goes out giving a bigger molecule, we call this a condensation reaction. And afterwards, I'll go to the next one. In the next one, again, we have from the alcohol, ethanol, we take ethyl part. Ethyl is, again, I'll keep it in red. Alcohol is ethanol. From the part of the alcohol coming from into the ester is named as ethyl. Ethyl. And from the propanoic acid, we have propanoate. Propanoate. Likewise, can you give a try to tell me the name of the third ester and the fourth ester? I want Chayomi to give me the third ester name, and then Ryan to name the last ester. Chayomi for the first one, Ryan for the second one. Tell me the name, please. Until you get ready with that, until you give the answer, I will get ready for the next part of the lesson. Means answer is the propyl ethanoate. Beautiful. Propyl ethanoate. Yes, it is propyl ethanoate. I'll write here. Propyl ethanoate. I'm waiting for Ryan's answer now. Ryan, it's okay even if you make a mistake, you give the answer. You are telling ethyl methanoate. Ethyl methanoate. Good. I'm not going to write it again. Good, good. Both have got the name correctly. Ethyl methanoate. Yeah. Now I'll try to draw the structures of these esters. First, let me take ethanol, CH3, CH2OH. I'll take the carboxylic acid part also. Ethanoic acid is CH3, COOH. Propanoic acid means 3 carbon containing carboxylic acid, CH3, CH2, COOH. Third one we have methanoic acid, HCO. I'll write like this. Now let us see the structure of the alcohol ester produced here. What happens is, from the alcohol part, hydrogen, and from the carboxylic acid, OH part goes out. These two will go out as a water molecule. Hydrogen from alcohol, OH from carboxylic acid, they get together and make water molecule. Then what happens afterwards? I can write CH3, CH3O. I'll write O like this. To this part joins at the functional group. So I write carbon. This oxygen is coming out as a double bonded oxygen, and then CH3. This is a ester molecule form. Black part is coming from the carboxylic acid. Red part is coming from the alcohol. Now I'll go to the next one. Again, a water molecule will be formed. Water molecule comes from carboxylic acid OH, alcohol, hydrogen. So this time I will write the ester molecule starting with carboxylic acid. Earlier I wrote alcohol part first, carboxylic acid next. Now I will write carboxylic acid first. There's no harm. CH3, CH2, And this carbon oxygen is coming like this, carbon oxygen. And then the alcohol part, oxygen, CH2, CH3. I'll do the same way for the last one also. First, I will write the carboxylic acid part. Carboxylic acid part is HCO. And now I go to alcohol part. Alcohol part is CH2CH3. This is how carboxylic acids and alcohols get together, making esters. However, for this reaction, heat is needed, and we have to have sulfuric acid also. Sulfuric acid is a catalyst. But if you write sulfuric acid just like this, you will not get marks, because for this reaction, we have to have sulfuric acid in the concentrated form. Conc H2SO4. Conc H2SO4. So remember, alcohols react with carboxylic acid when heated with concentrated sulfuric acid, giving ester molecules, giving out water molecules also at the same time. There is condensation reactions. Is it clear to you? Okay, here we have to fill this. We will try to complete this, draw the structures. First, I'll draw the alcohol structures. Ethanol, CH3, CH2, OH. Ethanol again, CH3, CH2, OH. Now propanol. Propanol is CH3, CH2. Propanol means 3 carbon. Again, CH2 and OH. Let's go to carboxylic acid part now. Butanoic acid. Butanoic acid means there are 4 carbon atoms. First, I will write CH3 here. CH2. Likewise, there should be 2 CH2 groups. So I write CH2 2 times. And COOH. Butanoic acid. Propanoic acid is CH3, CH2, COOH. Ethanoic acid is CH3, CH2, OH. Now, in your tute, can you write the formula of the esters? Names are given. I'll give about 2-3 minutes, and afterwards I will give the answers. You first write the answers for ethyl butanoate, ethyl propanoate, and propyl ethanoate, the way I explained to you earlier. Take 2-3 minutes and write correctly. Though I said 3 minutes, I think time is enough for you. Here, the name starts with alcohol part. This is carboxylic acid part. This is acid residue. This is alcohol residue. The meaning is this: when alcohol and carboxylic acid react together, You don't have the alcohol in the final ester. You don't have the carboxylic acid also, but we have the part coming from alcohol and we have the part coming from carboxylic acid also. So we call them alcohol residue and carboxylic acid residue. When you draw the structure of the ester molecule, it is not necessary to show the alcohol part first. So I'll start the work with carboxylic acid first. Carboxylic acid part is butanoate. Butanoate means 4 carbon atoms. So I'll start with this. CH3. This CH2 twice. I will write CH2, CH2. And then we have COOH. From this COOH, OH goes out, and we have carbon double bond oxygen. To that, the alcohol part is going to join. It is going to be OCH2, CH3 in the reverse order. O, CH2, CH3. And the example number 2. I'll start with propanoic acid part, CH3, CH2, COOH. It is going to be, let me start with blue. CH3, CH2, CO. Now the alcohol part, OCH2, CH3. O, CH2, CH3. Have we made this? Have we drawn the structure for the last one? Propyl ethanoate. Propyl ethanoate. First, I'll start with the carboxylic acid part. Oh, I made a mistake here. It should be C. This is not there. COOH. COOH. Ethanoic acid. So I'll start with ethanoic acid, CH3, CO. And alcohol part is O, CH2, CH2, CH3. O, CH2, CH2, CH3. I think we have got this idea.